Okay, in this video, we're actually going to apply and identify all of our transformations to make sure that we understood our reference sheet. So it says, given each function, identify both the parent function and the transformation from the parent function. So here, our parent function, if you take away all the multiplication, addition, subtraction, negatives, your parent function, f of x, is equal to just plain old x to the third power. Now the transformations, and we're going to list these like this. We're going to do all of our stretches, compressions, then we'll do all of our flips, and then we'll do all of our translations. Nothing is happening directly to the x. The only thing we have is a minus 4, which simply is a shift of our original function down 4. So it's a vertical translation down 4. Okay, number 2. Again, to identify your parent function, the easy way is to just take away all numbers, negatives, pluses and minuses, and you see that our parent function there is y equals the square root of x, or f of x equals root x. Now let's identify all of our transformations. Let's start with stretches and compressions. The 2 on the outside, and notice I said the outside. Here's what you've got to look for. Here's your square root function, and the x is on the inside. Any multiplication on the outside will be a vertical stretch compression. Since you're multiplying by 2, that'd be a vertical stretch times a factor of 2. So we're done with everything on the outside. So now let's travel to the inside and look for, again, look for stretches and compressions first. There are none. So now let's go to our flips. The negative on the inside, and again, since it's on the inside of the function, the negative on the inside will flip our function across. It'll flip it horizontally because it's in there with the x, so that'd be across the y-axis. And finally, our last transformation is that minus 1 on the x, and the minus 1 would shift it, again, backwards from what we think because it's in there with the x. It would shift it right 1. Okay, number 3. Again, let's start on the outside and look for all stretch compressions. There are no stretches on the outside, so now let's go to the inside, and there is a stretch compression here. Since it's been multiplied by the x, that would be horizontal. And anytime we're talking about horizontal stretch compressions on the inside, we do have to flip it to find out our scale factor. So times 1/4 would flip, and that would be a scale factor of 4, so that would stretch it. So it'd be a horizontal stretch times a factor of 4. We actually forgot to identify our parent function there, and it would be just f of x equals x squared. And again, let's go ahead and now write down as well our horizontal stretch. And that should take care of all of our stretch compressions. We do have a flip. It's not inside with the x, it's on the outside of our function. So that would be a vertical flip, an up and down flip, so that would flip it across the x-axis. And finally, our last transformation would be this plus 6 out here. It's on the outside of the function, so that would be simply a vertical translation up 6 units. And that would be all of our transformations on that one. Number 4. Again, let's start with all stretches and compressions. You have none on the outside, but you do have one on the inside. This multiplication here, again, since it's on the inside with the x, that'd be horizontal. We're going to have to reciprocate it to find our scale factor. So their scale factor would be 1/3, so therefore we would compress it since it's less than 1. So a horizontal compression times a factor of 1/3. And there are no negatives being multiplied by inside or on the outside, so therefore there's no flips. However, we do have 2 different translations. The one on the inside, the plus 5 will actually shift it backwards. It's going to shift it, since it's in there with the x, it's going to shift it horizontally left 5 units. And then the minus 2, since it's on the outside of the function, would be a vertical translation, and it would move it exactly what it says it would. It'll move it down 2 units. And that takes care of all those. Number 5. Our parent function, again, take away everything here, and you're left with x squared, so that'd be your parent function. F of x is equal to x to the second power. Going through all the different transformations. We'll start with stretches and compressions, and you do have a 1/2 on the outside of the function. It's not inside with that x, so that would be a vertical, and it would stretch it by a factor of 1/2. And that's actually a compression since the scale factor is 1/2, I said a stretch, but that would be a compression. And then the last thing that you've got is this -6 on the inside. A -6 would shift it to the right 6. It's opposite from what it says it would do. So that'd be a horizontal shift or a horizontal translation right 6 units. And that should be everything. Moving on to number 6. Now this one's a little bit more difficult to identify. It's not as common of a function. Let's get rid of this minus, get rid of the 4, being multiplied, get rid of the 3. So your parent function here is y is equal to 1 over x. Again, it's not a function that we deal with as much. So now let's go back and talk about all the different transformations. And the first one's kind of confusing because let's talk about our stretches and compressions. And the question is our x being multiplied by 4? And it looks to be, could we put parentheses around that and say x is, and yes, that would be a horizontal compression by 1/4. However, we could also say our original function, which is 1 over x. We could say it was being multiplied by 1/4 because 1/4 times 1 over x would give us this exact same 1 over 4x. So which one is right? They both are. You could say it either way. You can say that either the x is being multiplied by 4 or the whole function is being multiplied by 1/4. You would actually get the exact same picture regardless of which transformation you did. So we'll call it a vertical compression by 1/4, but again, you could call it a horizontal compression by a 1/4 one as well. The negative is the same confusion because if you look at this negative 1 over x, well, is that negative times the original function? Or is that 1 over, could we put the negative on bottom? And again, either way would work. So you could either say that this is a vertical flip or a horizontal flip. And the reason for that is because no matter if you flip it horizontal or vertically, if you look at what the function actually looks like, it's something of this nature. And whether you flip it here and here, or whether you flip it here and here, it actually looks identical regardless of what you do. Then the last transformation is going to be this +3 out here, which simply moves it up 3 units. And that should be all of them. Let's go on to the next one. All right, number 7. First off, let's identify the parent function by getting rid of all multiplication, addition, and we see that the parent function will be f of x equals the cube root of x. First off, let's look for any kind of multiplication that's going to stretch or compress. I do have one on the outside, so that'd be vertical. So it does exactly what it says it's going to do. That's going to be a vertical stretch times a factor of 4. And that should be all of our stretches and compressions. Let's look for any flips, and negative multiplication is going to flip it. We do have another one on the outside, so that's going to be a vertical flip. And an up and down flip would be a flip across the x-axis. And then the rest of the transformations we have are translations. Inside with the x, a +1 would move it left 1, and the 2 on the end would move it up 2. And I went ahead and just combined those into the same step there. Number 8. Here you have the floor function. So you can take away the -5 and division by 2 and all that. And you got f of x equals the floor function of x. And again, you can use the symbol that they used here or the floor function symbol, either one. Let's look for any multiplication and division. Now the inside, we need to get used to this. Anytime you have x minus 5 divided by 2, that can be rewritten as 1/2 of x minus 5 to make it look more like what we're used to. Division by 2 is the same thing as taking half of something. So that way you can see the multiplication. We look for any kind of multiplication first for stretches compressions. And since you do have that multiplication by 1/2, which we can see here, inside with that x, that's going to be our first stretch or compression, our dilation. Since it's a 1/2, we do have to reciprocate it since it's on the inside. So that'll be a times 2, so it'll be a stretch. So that'd be a horizontal, because it's inside with the x, a horizontal stretch by a factor of 2. And the only other 2 transformations I have are translations. Inside with the x, I have a -5, which would move it right 5, opposite. At the end, I have a -1, which would move it down 1, and that's it. Translations, right 5 and down 1. Okay, number 9. Look for multiplication and division first, and I do have the 1/3 right here. It's inside with the x, so that would be horizontal. Let's identify the parent function first. F of x equals, take away all the multiplication, the pluses, the minuses, and it leaves you with the absolute value of x, our V-shaped graph. Then we move on to the 1/3. Since it's inside with the x, we're going to reciprocate that, and it's going to change this by a factor of ×3. So that'd be a stretch. Since it's inside with the x, that would be horizontal. So horizontal stretch by a factor of 3. Along with that, we do have a negative, and we know that multiplication by negatives are going to flip it. Again, since it's inside with this x, inside the absolute value bars, that would be a horizontal flip, or that'd be a flip across the y-axis. And finally, we just have two translations. -4 inside with x, move it right 4. A +7, we'll move it up 7. So again, translations right 4 and up 7. Okay, that should do it. Number 10. First off, identify your parent function. Take this away, and you have x to the third stuff. So it'd be f of x is equal to x to the third would be the parent. Let's look for any multiplication or division. There's nothing inside with the x. All we have inside with the x is x plus 3. That's all the horizontal action that's going on. But we do have a 3/2 on the outside, so that would be a vertical. Since it's bigger than 1, that'd be a vertical stretch by a factor of 3/2. On that 3/2, there's also a negative symbol, which is going to flip it, and it is also on the outside of the bars here being raised to the third power. So that negative would flip it vertically as well, so that'd be across the x-axis. And then finally, the +3 on the x would move it left 3. The -8 on the end would move it down 8. So that'd be translations left 3 and down 8. Okay, in the next section, it says using the graph of each function, identify the parent function, then write an equation for the function under each transformation. So we're working these backwards. First off, let's identify our parent function. Anytime you have that V-shaped graph, that is going to be f of x equals absolute value of x. And then on B, it says, how would we translate that 4 units to the right? Well, first off, we need to identify the fact that that's a horizontal translation. So it's going to be happening inside with this x, and it's going to be happening backwards. So 4 units to the right would be the function. We're going to take our absolute value of x, and in order to move it 4 units to the right, we're going to do a -4 to the x. Well, how would we reflect it in the x-axis? And the word in, again, means across. How would we reflect it across the x-axis? And across the x-axis would be not that way. That's going to be across y-axis, right? So across the x-axis, that would be a vertical. So we're going to flip it vertically. So that means it's not going to happen inside with the x. Let me put vertical right there. That's going to be a vertical flip. Then we're going to move it 5 units up. So let's take our original parent function, absolute value of x, and to flip it vertically, don't apply it to the x, but apply it on the outside. And then to move it 5 units up, again, up and down will be on the outside, so that would be your new function. Next up, the parent function here, that looks like f of x equals 1 over x. Now we want to translate that 7 units down, so that'd be vertical. 3 units left would be horizontal. So we're going to take our function. Let's start with the 3 units left. That'd be 1 over. It's always backwards. So to move it left, we're going to take our x and add 3 to it. And then to move it 7 units down, we're going to take the whole thing and subtract it by 7. Next up, how would we take that same function? Let's take our 1 over x. How would we first horizontally, and that would be applied to the x, stretch it by a factor of 3? Now this gets a little tricky because what we've actually got to do to stretch it by a factor of 3, since it's horizontal, we've got to multiply x, because it's horizontal, by the reciprocal. So that's going to turn this into 1/3 x on bottom. So let's try to see if we can't clean that up before we move this thing right 2 units. So 1/3 times x on bottom can be written as x over 3. So we have 1 divided by, let me change that to now an x over 3. to divide two fractions, you flip the second one and you multiply. So that would actually turn into 3 over x. Okay, and that would stretch it horizontally by a factor of 3. We actually multiplied by the bottom, the x, by 1/3. Now we got to move it 2 units to the right. That's pretty easy. We're going to take our x value and simply do a -2. That would move it right 2 units. Horizontal because it's left or right, and then -2 would move it right. It would always move it opposite. This next one is our step function, our greatest integer function. So your parent function will be f of x is equal to the floor function of x. And again, you can use that notation or you can use this notation, either one. To translate it 1 unit up, okay, let me rewrite the function here. And let me leave some space inside there just in case. And I'm just going to use this notation here. 1 unit up would be a +1 on the end. A vertical stretch, okay, anytime you're going to do it vertically, again, that's going to apply on the outside out here by a factor of 4, so just put a 4 out there because it actually happens the exact same way it says, and I can now clean that up a little bit more. So again, that notation or this notation, either one will work. Vertically compress, okay, so that's still f of x equals, let's skip over. We got our x on the inside, and I will leave a little bit of space in case we need to change it. Vertically compress. Okay, if we're multiplying by something vertically, it's going to be on the outside by a factor of 1/3, so simply multiply by 1/3. And translate it 6 units to the left. Okay, that'd be on the inside, that'd be a +6 to move it 6 units to the left on the inside. Okay, number 14. Your parent function here, f of x, equals the cube root, and you can check all these with your list of parent functions. To reflect it in the y-axis, that's to reflect it across the y-axis. So that'd be a horizontal reflection, so that's going to happen to the x. So we're going to take our original function, cube root of x, and in order to flip it across the y-axis, in order to flip it horizontally, we're going to change this to a -x. We also want to translate it 4 units to the right. Now we always want this in factored form on the inside, so I'm going to put in parentheses the negative out front, and then 4 units to the right would be an x -4. And then C part, horizontally compress. Again, that's going to be happening on the inside if we're compressing horizontally, so let me write my function again. To compress by a factor of 1/2, we're going to multiply by the reciprocal. So on the inside, this would actually compress it by a factor of 1/2. To move it 5 units down, come on the outside out here and simply subtract 5. Okay, number 15 says if a function f of x is reflected across the y-axis, then translated 6 units down and 2 units, rise 6 units and down 2 units, write the equation of the new function. So we're actually going to transform a transform function a little bit more. So we're going to take this f of x equals 2 parentheses x -5 squared plus 3. Okay, first off, to reflect it across the y-axis, that's going to be left to right. That's going to be a horizontal reflection. So that negative is going to happen on the inside. So let's come on the inside here, and let me write this as some brackets just so it'll look better. Okay, that x -5, to reflect it, we're now going to put a minus in front of it. So we have minus x -5, that's going to reflect it. Then we're going to translate it 6 units to the right. So it's already been translated 5. Let's translate it 6 more. So now it's been translated 11. So left 5 and then left 6, or excuse me, right 5 and then right 6 more. Now let's go down 2 units. So we're up here at +3. So down 2 from there would just be a +1. Okay, number 16 says a function was vertically stretched by a factor of 2, then translated 2 units left, 5 units up. The resulting function is represented by this. Write the original function. So now we're going backwards. So our new function is this, 6 absolute value of x plus 4 minus 1. Okay, so our original function was stretched vertically by a factor of 2. So this started somewhere else and then got stretched times 2 more. So it must have been a 3 before if it got stretched by 2 and turned into a 6. Then it got translated 2 units to the left. Okay, it's at x plus 4 now. So this has been translated 4 units to the left, so our original function got translated 2 more, so it must have started at x plus 2. It must have got translated 2 units to the left. Let me zoom in there. Erase that. So if it's at x plus 4 now, it must have started at x plus 2, translated 2 units to the left, then it would have turned into that. Okay, the minus 1. Now we're at minus 1, but our original function was translated 5 units up to get here. So now we're down 1, so our original function must have been down 6 to have been translated up 5 units to end up at minus 1. So this must have been our original function.